Hi everyone, myself Anarun Kumar from SNS College of Technology in the Department of EC. In this video, I am going to share about domain specification from frequency plot in frequency response analysis. The last two videos we have discussed about polar plot and Bode plot of the systems, so that we need to know the corresponding informations based on magnitude and phase of the systems for both the systems. So here the frequency plot has been exactly identified with the help of the domain specification of the systems, because number of frequencies are high when compared with number of signals, so that we need to know the domain specification of the systems based on the frequencies plot. Understanding the users and system needs, because based on the frequency only the system responses has been executed with the help of the signals, and it is purely based on the domain specification for generating the frequency plots in control systems. And next one is understanding the frequency responses. For example, if you are taking radio systems, for example, take any one radio station like Surin FM, it is having some frequency. So like that, all those defined systems having their own frequency process. So we need to fit the frequency process based on the input and output signal of the systems. For example, like Surya FM, it is having some set of frequency responses. So from that only we need to get the signals for their station, or else we don't get any signals from the particular station. Somewhat we need some we get some noises from the station if we are crossing other frequencies. So the particular frequency has been fetched by using this concept. So that's why define has been identified by using this frequency responses. And next one is key frequency domain specification. The frequency responses purely formed with the help of these two factors, resonance frequency and gain margin and phase margin. So once if you are fix the frequencies for the corresponding stations, these two factors define exactly the particular frequencies of the systems as resonance frequency omega r, because we need to check which is the marginal of the frequency of the system, so that we need to fix the resonance frequency as critical one. And next one is gain margin, phase margin. It's already decided because the exact frequency and their bandwidth and angle to be monitored with the help of this gain margin and phase margin of the systems. And next one is visualizing the frequency response. So for suppose if you want to fix the frequency response as high in the system, means the particular system and the particular frequency response is only to be monitored for the process, and the exact and or exceed level of the system to be monitored with the help of neighboring systems. So these two plots to be identified by using this magnitude plot and base plot of the systems. And next is Nyquist plot and stability insights. Suppose the user has to launch same frequency for two system, means we need to verify the magnitude phase of the system based on the margins. Suppose the system is how much margin to be fetched. So like this, the another system to be checked with the help of this Nyquist plot and stability insights. On relationship between the frequency and time domain specifications. The pure difference between this difference is bandwidth and rise time only. Bandwidth means difference between two signals, and rise time means exact location of the highest frequency of the system. And next one is resonant peak and overshoot. It is known that the particular frequency may not process other signals or other systems. So that is why we are using here as a resonant peak and overshoot of the systems. And next one is evaluating system performance. After finalizing all those frequency responses and their characteristics, then we need to evaluating the system performance by using a frequency characteristics, so that we need to execute the particular frequency of the system by using a system responses. The summary: a frequency domain for the control actions, critical insights and effective decisions. Critical means the overlapping of the noises, and effective design means to avoid the noises of the system and improve the stability and bandwidth of the systems. The activity is given as group discussion, domain specification from frequency response plots in control systems. Identify objective is to analyze the how frequency domain specifications obtained from the plots like Bode plot and Bode plots help in evaluating the system performance in real-time control systems. So with the given time is 20 minutes, 20 to 25 minutes, and we need to verify it based on gain margin, phase margin, bandwidth, and resonant frequency. Based on this, we need to clarify about this group discussions. Assessments. The angle of the point in a polar plot represents gain margin, frequency, phase angle, time delay. The answer is phase angle, because the phase angle only defines the particular angle of the systems, particular frequency of the systems. And next one is the magnitude in a polar plot is represented by angle from the origin, distance from origin, slope of the curve, frequency axis. The answer is distance from the origin, because the distance only exactly defines the bandwidth of the systems. Thank you. And this D flip-flop is executed purely based on the frequency response characteristics, because if you are having a frequency response, then we need to identify the timing parameters, aging parameters, and the practical applications, and why we are using this flip-flop. So these are all the parameters to be known by using this slide. So these are all the references I have taken for this video. Thank you.